Let's next look at soil water retention. Now, what does that term retention mean? Retention is referring to the ability of the soil to hold or retain water against the pull of gravity. Obviously, soils will vary in terms of how much water they can hold against this gravitational pull. There are two conditions that we need to discuss as related to soil water retention. The first of those is what I will call saturated. Soils that are saturated are retaining water above the normal gravitational pull. In order for this to happen, what that means is that there has to be something in that soil profile that is causing the free water, also sometimes referred to as excess or gravitational water, not to flow out of the center of these soil pore spaces and on downward in the soil profile. Oftentimes this can lead to conditions which are referred to as waterlogging, which obviously cause poor plant growth as well. Saturated types of soil water retention are being caused by some type of impervious layer in the soil profile that is restricting the movement of water, normal movement of water downward due to gravitational pull. Under most field conditions, this does not occur and therefore is not as important in our conversation as is unsaturated soil water retention. We are going to spend most of our time on unsaturated soil water retention. All I will say about saturated water flow is that it does obviously occur below the level of the water table in the soil. The water table being the level of freestanding water, where water is actually there under pressure, not under tension. It can also occur near the soil surface in some areas where we have a shallow water table. This would be considered a disadvantage if it does not allow enough soil profile for effective rooting depth of a crop. But in a few isolated situations, it can also be considered an advantage. And one example would be where we have a impervious or restrictive layer occurring, say, a few feet below the soil surface. This allows that soil above to actually retain water at a higher level than it normally would. We are aware of this situation. We utilize irrigation to fill that profile up to whatever level it can possibly hold. But yet still allow enough aeration in the soil for effective root growth and metabolism. So under those types of situations, we somewhat times will call these soils sub-irrigated because the water table is close or it has an impervious layer that causes extra water retention above the normal level. That does not occur over a very large percentage of the Earth's atmosphere or the landscape. Under most situations, water is going to be held in the soil profile under less than saturated conditions. We're going to next look at what are the forces that are causing the soil to be able to retain water against this gravitational pull. You'll recall earlier when we were discussing the water cycle in nature that the term capillarity or capillary water showed up on that diagram. That term will be utilized again in relationship to the retention of water by the soil particles. The two forces that are acting in terms of allowing these soil particles to retain soil water are the processes of adhesion and cohesion. The term adhesion is referring to the attraction of the water particles or molecules, in this case the hydrogen portion of the water molecule, to the surface of the soil particle itself. Now you'll recall that the soil particle surface has a net negative charge due to unsatisfied oxygen anions that are part of that mineral structure. This unsatisfied negative charge has a strong force of attraction for the hydrogen portion of the water molecule. Therefore, this force of attraction of the hydrogen portion of the water molecule to the negatively charged surface of the soil particle is referred to as adhesion. Soil particles virtually build up a film of water around their surface, partially due to adhesion at the surface and also partially due to the process of cohesion. Cohesion is related to the fact that water molecules have a strong attractive force for each other. So if this is HOH or H2O water, if this is one molecule, here's the next water molecule lying next to it. The hydrogen portion of one water molecule is attracted to the partially negatively charged oxygen of an adjacent water molecule. Since water is a polar liquid, meaning it has partial negative charge on the oxygen and partial positive charge on the hydrogen, these molecules of water are strongly attracted to each other and held together tightly. That force of attraction of one water molecule for the next is called cohesion. So adhesion attracts them to the soil particle surface. Cohesion allows these water molecules to build up in films or layers around the surface of this soil particle. Both processes together, the process of adhesion and cohesion, have a substantial amount to do with the retention of water in the soil by the soil particles. Now, from an earlier conversation we had in the unit on physical properties of soil, we learned that different soil textural classes have different abilities to hold water. They do hold different amounts of water based upon one important criteria being the surface area. You recall also from our previous conversation, as the size of the soil particle decreases, the amount of surface area in a given volume of soil increases. That is to say that sandy or coarse textured soils have less surface area on the mineral particles than do silt-sized particles, which are correspondingly less surface area per unit volume than our clay-sized particles. So as we decrease the size of the mineral particles in the soil, which is to say we increase the silt and or clay component of the soil at the expense of the sand, we see a greater amount of surface area and therefore a greater amount of soil water retention by these finer textured soils than we do for the medium and or coarse textured soils. We are not talking about available water here, we're talking about the amount of total water that's being held by the particles, the mineral particles in the soil. Due to the fact that these pores in the soil, the spaces between the soil particles, act similar to capillary tubing, small diameter glass tubing, this water held in these soil pores is oftentimes referred to as capillary water. With the help of the next graphic, we'll further explain the concept of capillary water and capillary rise of water in the soil profile.